Okay, for example 3, I'm going to use a fact that I just gave you a moment ago about complex answers in order to help me determine what's going on here. P of x equals this, and we're told that 2 plus I is a 0. Okay, we're told that it has a complex 0. And I can see with my eyes that all the coefficients are real numbers. So what I just told you a moment ago was if there's a complex 0, its conjugate is also a 0. So that's a lot of information because they actually gave us 2 answers. How many answers do we need to have?
4.
But how many do we need to have to get it down to a quadratic? We need 2, right? All right, so all we need is 2 answers. We got our 2 answers. But here's the problem. If I try synthetic division, 2 plus I goes up in this little corner. 1 minus 4, 14 minus 36, and 45 go here. Guess what the remainder is? The remainder is 0, right? Because it's a 0. But can you imagine 2 plus I times 1, and then add that, now you get negative 2 plus I times 2 plus I. Now you're going to get a big mess in here. It gets really ugly, really fast. So I'm going to show you a present I gave all of you on your calculator. It's called SynDiv. Okay, if you hit the program button, you got SynDiv, which is the granddaddy of all the SynDiv programs. You want to always open that one. And then SynDiv 2, 3, 4, and 5, because we don't go ever above the 5th power. All right? 2 represents 2nd, 3 third, 4 fourth, 5 fifth. Okay, so if you want to just pick SynDiv 4 immediately because it's 4th power, that's fine. All SynDiv does is ask you, so if I type in program 3, so it says program SynDiv, enter, it'll ask for the degree. Okay, the degree is the highest power, and that just opens the correct SynDiv program. Then all it asks you for is the coefficients, which would be what we have over here, one at a time. So 1, enter, negative 4, enter, 14, enter, negative 36, enter, and 45, enter. Make sure when you type in negative 4, negative 36, use the negative key, not the minus sign. Otherwise your calculator gets bent out of shape, doesn't understand that. Then it asks for the root. The root is whatever goes up in this little corner here, in this case 2 plus I. And again, in my mode, I am at A plus BI form. It's not letting me go in there right now, but you have to be in A plus BI form in your mode. So 2 plus, and I is right here above the decimal point. You have to hit the second key. Second decimal point, 2 plus I. Okay, what SynDiv is going to do when you hit enter is it's going to give you, right here, a list of what goes down here, one at a time. So the first number is 1, the second number is negative 2 plus I, the third number is 9, the fourth number is negative 18 plus 9I, and the last number is 0. The last number sometimes isn't 0, sometimes it's like negative 1.7 e negative 8 or something like that. That's negative 0.00000017. So it basically is 0, but sometimes with rounding, sometimes the calculator doesn't get exactly 0. But this last number, if it's not 0, it'll be like an e negative 7, e negative 8. So it'll be like a bunch of zeros followed by some decimals. So just pretend it says 0. All right, that's the only one that ever messes up is that last digit. So again, it just performs synthetic division. You don't have to go through all the mess, but again, if I was to do it for real, 2 minus I times 1 is 2 minus I, right? Plus 4, negative 4 and 2 make negative 2, then the plus I. This times this makes negative 4 plus or minus 1, so negative 5. Just take my word for it, it does. 14 minus 5 is 9. 2I times 9 makes 18 plus 9I. Negative 36 and 18 make negative 18 plus 9I. And that times that happens to make negative 45, which makes 0. So it's doing all the math you need to do. It's just giving you the results. It's not giving you this line here. So just keep that in mind if you're going to use the program. That's how it works. All right. Our reduced polynomial now has all these coefficients. Notice we got some complex coefficients. That doesn't matter. My root is 2 minus I. My calculator is able to handle such a thing. What degree is this one? Third. We started off with 4th, we did a division, and we're down to a 3rd. So again, I'm going to run my SynDiv program again. If I hit enter, it automatically runs SynDiv again. Or you can hit program SynDiv. All right. But then my degree is 3, enter. And now it wants the coefficients again. So again, I start by typing the coefficients. 1, negative 2 plus I. Again, I is second decimal. Enter. Positive 9, enter. And then negative 18 plus 9I. If it was negative 18 minus 9i, then you can use the minus key on that one. Always the negative, the very first thing being negative, use the negative key. If it's a subtraction, you use the minus key. As far as my root is concerned, it's 2 minus I, so 2 minus I. Oops. I, answer. 2 minus I. And there's a situation where I use the minus sign. Minus I. Hit enter, and 1090. Those are pretty numbers. We should get pretty numbers on the second one. After the first imaginary, you should get some imaginaries on the second one. Should be back to reals because you took care of the complex number and its conjugate. The remaining answers are either conjugate complex numbers getting you back to reals, or just reals, which should be real. So these should always be real numbers after you've done both a complex and its conjugate. All right. So there's two of my solutions. The other two solutions are going to be x squared plus 9 equals 0, which means x squared is equal to negative 9, which means x is equal to plus or minus the square root of negative 9, better known as plus or minus 3i. And it just says find all the zeros this time. It doesn't do all that stuff about the linear factors. So x equals 2 plus I, 2 minus I, 3i, negative 3i. Notice that one had no real answers, so they had to give you that information about the complex root in order to be able to break it down. All right? And if it does say find all the zeros, include the one they gave you in your list. Don't just, sometimes they say find the remaining zeros. I still want you to list all the zeros. So always list me all the zeros of every problem when you get to these problems in your homework.